So in this video, I want to talk about what delta H is. What it is pretty much a change in energy. And I think before we kind of get into the details of Hess's law and then kind of going through problems, I want to explain the difference between endothermic and exothermic. So here's a reaction. I'm going to put it in the box to kind of simulate a system. And if a reaction needs energy for it to work, that means I'm going to input energy into the reaction in order for it to get started. So that's endothermic, meaning it's going to take in energy. So if you think about it, if this was an energy graph, in order for it to happen, you're going to have to increase the energy. Initially, it doesn't have that much, and you're going to input it, so it's going to store it up in whether it's bonds. Most likely it's bonds. So you're creating bonds that are going to have more energy than was before. So you're inserting energy to kind of create the new things. I think the classic one that we talk about all the time is sugar. So you have, let me make sure I get this right, H2O plus O2 plus energy is going to make us C6H12O6 plus CO2. So this is the equation for making sugar or glucose. And what needs to happen is that the plant is going to absorb energy from the sun, and it's going to create new bonds in this chemical formula or in this chemical molecule. And in this sugar, you're going to store a lot of energy. So you're going to input this energy to get sugar. Now, in an exothermic reaction, the opposite happens. When the reaction happens, instead of inputting energy, you're going to so energy is going to exit. So what's going to happen is, let's say we're going to consume the energy of sugar. So what's going to happen is you might have to do a little bit of activation energy, but once that happens, the sugar is going to come out. So another way example is you could burn sugar. So if you just get a match and light it up, once you start the activation energy, all the energy is going to come out, and this is going to be exothermic. Now the difference between the two is the delta H. So remember, H is the amount of energy. Here, the delta H, you're starting from down here. So let's make up a number 1. And you're ending up here. Let's just make up a number 2. So final minus initial, 2 minus 1 is a positive number. So here, delta H is positive. Now let's do the same thing. Let's name this 2 and let's name this 1. Here, the delta H, you're going from 2 to 1. So final minus initial, so 1 minus 2 is going to give you a negative number. So when you have an exothermic reaction, that's going to be releasing energy. It's going to be a negative delta H. If you're an endothermic reaction where you need energy for it to happen, it's going to be a positive delta H. Now, for example of exothermic, is just the opposite right here. So here, when we consume glucose and we eat it, our bodies are going to convert that to energy in the form of ATP, and it's going to go this way. So hopefully that makes sense why delta H is positive when it's endothermic and negative when it's exothermic. Now here I have two equations to the right. I have hydrogen peroxide is going to break down into water and oxygen, and then I also have two hydrogens and oxygen, and they're going to form water, and this happens very easily. So when you look at both of these are both negative delta H's, which means that it's going to be a exothermic reaction. So what we want to do though is, sometimes we know these values, so a lot of times in the back of a chemistry book, or you could just Google it, you can find the delta H of chemical reactions. Sometimes you want to do a chemical reaction that you don't know the results of. So in this case, we want to know what the delta H of hydrogen peroxide breaking down into hydrogen gas and oxygen gas. So you could technically put in a calorimeter and kind of figure out what's going on. You could do the opposite thing, is do a couple of steps and figure it out. But a lot of times what's even nicer is that you could just figure out how to do it by combining two known facts. So I know the delta H for this reaction, I know the delta H for this reaction. So if somehow I can manipulate these two to this one, I could do the same thing. So what I like to do normally is look for the most oddest kind of chemical molecule. So in this case, H2O2 is probably the one that's going to stand out the most. And you can see it right here, and it's not in the other equation. Here, it's both on the left side, so I'm pretty happy. They're both on the left side, so I'm good. Now, unfortunately, for the right side, I have H2 and O2, which is neither of these. This is 1/2 O2, but it's H2O. So I need to somehow get this without the H2O. Since the H2O here is on the left side, what I'm going to do is I'm going to flip the bottom one. So then you're going to have 2H2O. So all I'm going to do is moving this to the other side. And then I have 2H2 plus O2. Now, unfortunately, here it doesn't cancel out. Here I have 1H. So here I have 2. So maybe instead of just flipping, I'm also going to multiply by 1/2. So when I do that, this 2 now becomes 1. This 2 also becomes 1. And this 1 becomes 1/2. So let's see if that cancels out certain things that I have that I don't want. Because in the final product, I don't have water. I have one water here. So in this case, the waters do cancel out because they're on the opposite sides of the arrow sign. Did I leave out? No, I didn't leave out anything. Here I have 1 hydrogen, which is I'm okay with. Here I have 1/2 oxygen. So I'm okay with that as well. So now I'm going to add everything on the left side together. So I have H2O2. I have nothing here because it crossed out. So here's my arrow. I have 1/2 O2. And then I have 1 H2. And then another 1/2 O2. So now I'm going to combine like terms. H2O2 is going to give me 1 O2, or just O2, plus 1 H2, which is H2. So now I have this equation, which looks just like this one, and I'm good. So now, in order to get my delta H, I'm going to go, okay, what did I do? Here I did absolutely nothing, so I'm going to keep this number exactly how it is. Here I flipped, and then I multiplied by 1/2. When you flip, this delta H becomes positive, and then I'm going to divide it by half, so I'm also going to have to multiply this by 1/2. So I'm going to put that in my calculator. 571.6 times 0.5, or divide by 2, and I get positive 285.8. So I'm going to now add these two numbers together. And I get a delta H of 187.8. Okay, so that's how you do it in this way. What's cool is that you could use things that you know to kind of figure out things that you don't know. So let me know if you have any questions.